Hello everyone and welcome to T's channel. Today we're going to be finding the arc-length of the function given by this formula, and the function we're going to be finding the arc-length is this function over here is an interesting function, one which I've come across. You might want to pause the video and give it a try. In the meantime, we'll delve right in. So one thing I want you to notice before I solve this is this part of the question. So this is going to be my process of solving it. I'm going to first find f prime of x, which is simply the derivative of this function, and then I'm going to go ahead and square that after finding the derivative. So that's what we're going to do in solving this question before we impute it into this formula. So delving right into that, we're going to use a red pen and we're going to solve. And solving that function, we have the y. I wanted the darker shade, y is equals to y prime is equals to, what I'm simply going to do is that since there's a plus and addition sign in between both of them, then this is just a composite function, right? So you can see it is this prime plus this prime, right? So if I solve that, that's going to give me, if I solve this using chain rule, I'm going to just have half e raised to the power of half x minus half e raised to the power of negative half x. That's what is going to be my derivative of the function. Now, before I go ahead and square this, I'm going to make it a common fraction. So this is going to be e to the half x minus e to negative half x. That's what I'm going to have. Now, remember our original function was L. I'll draw a border over here. Is equals to integral b square root of 1 plus f prime of x all square dx. So we're going to square this function now. And in squaring that function, we have that this is supposed to be y prime, by the way, guys. We're going to have y prime all square is going to be equals to e to the power of half x minus e to the power of negative half x, everything all squared, and if I squared the denominator is going to be 4. Now, we're going to use the fact that when we have a minus b all square, it just simply give us a square minus 2ab plus b square to solve this first part of the question. So, if I should do that, I'm going to have that y prime all square, because to solving this is going to be the square of this, that's a square, which is just going to give me ex minus 2 times. Now, this, if you solve this, multiply by e power of negative half x plus, it's just going to give me e to the power of negative x. If I solve that, that's going to be all divided by 4. Now, you notice that this, if we solve this part of the question over here, if I should solve that, that's going to give me e to the power of 0, which is equals to 1. So at the end, I'm going to have just 1 times 2, right? Since that's what I'm going to have, since that's what I'm going to have, I'm going to just say y prime all square is just simply e to the power of x minus 2 plus e to the power of negative x all out of 4. Now I'm going to impute this into our formula. So just for a quick reminder one more time, remember that our formula was L equals to integral b a root 1 plus f prime of x all square dx. So when we impute that, we're going to have that L equals to um integral of, our range was from negative 2 to 2. We're going to have the square root over here of 1 plus, now we're going to have a function e to the power of x minus 2 plus e to the power of negative x all over 4 dx. I mean, we already squared it, that's why we did not do this. Now, what are we going to have next? When we solve for this, we're going to have that L is equals to, if I find the integral of 2 to negative 2, what I'm going to do is that I'm going to solve for what is inside this bracket. And if I should find the common denominator is 4, and this is going to power 4 plus e to the power of x minus 2 plus e to the power of minus x dx. Now I can simplify that further to get L equals to integral of 2 to negative 2. I'm going to have this out of 4. I'm going to have e to the power of x plus 2 plus e to the power of negative x. Now, this is an interesting situation. I mean, you could go ahead and try to solve this, but you might get stuck. So what I would do is, remember that when you have a plus b all squared, it gives you a squared plus 2ab plus b squared. Now, let's take a look at where we have e to the power of half x plus e to the power of negative half x all squared. If we're using this formula, it's going to give us e to the power of x plus 2 plus e to the power of negative x. which you can see that this is equals to this. And since they are equal, I can just substitute this for this over here, right? That's what I'm going to do. So for that, I can have that my arc length L is equals to integral of 2 to negative 2 square root of, and I can just have what? E to the power of half x plus e to the power of negative half x all squared over 4, which is pretty simple from here. If I solve, I'm just going to have that L is equals to integral of 2 to negative 2. That's going to be e. This is going to take out the square root. And you know that here is going to go to 2 e to the power of half x plus e raised to the power of negative half x over 2. Now, we're always forgetting about the x, so we should include all that. Now, if we solve this integral, we're going to have, I can bring this LCM out 1 over 2, and then I can find the integral of this. The integral of this is just going to be 2 e raised to the power of half x minus the integral of this is going to be 2 e raised to the power of negative half x to negative 2. That's going to be our integral. And you can notice that these 2's here cancel out if I should open the bracket. So I'm just going to have my arc length. If I'm substituting, I'll first start by substituting 2. It's going to give me e raised of 1 over 2 x minus e raised of half x whole squared. This is what I'm going to end up with. So negative 2. And then let's quickly substitute. I'm going to have that our arc length is equals to, firstly, we'll have e raised of 1 over 2 times, this is going to be times 2 minus e raised of 1 over 2 times 2 minus e raised of 1 over 2 times minus 2 minus e raised of negative 1 over 2. This must be negative 1 over 2 times minus 2. And this is going to give us that L is equals to, this is going to give us e raised of 1 minus e raised of negative 1 minus e of negative 1 minus e to the power of 1. This is going to be plus. And then we're going to have our arc length is equals to 2 e raised of 1 minus 2 e raised of negative 1. Now you can use a calculator and solve this. But pretty much I know I am not allowed calculators in calculus exams, so leaving this as your final answer still gives you a